Lidert for the introduction. So as you mentioned, this webinar is organized as part of the Odyssey project, which aims to track energy efficiency progress in Europe. The project is funded by the European Commission through the LIFE program. It comprises two databases, Odyssey for data and indicators, and MUR for policies and measures, supplied both of them by contribution from a network of 40 national partners. This webinar relies mainly on Odyssey database and facilities, which provides data up to 2022. You can find much more information, data, and analysis on our website. So first, I will present the trends in energy consumption and CO2 emissions in the EU. Then Bruno will analyze energy efficiency trends. And finally, Wolfgang will talk about the contribution of energy efficiency policies. So let's begin with total energy supply, also called primary consumption. As you may know, it is partly related to economic activity, so it is interesting to compare its evolution in orange with the evolution of GDP in green. You can see in light orange the evolution of primary energy intensity. At EU level, we observe large fluctuations in total energy supply since 2020. There has been a large decrease since 2022 due to price rises in 2022 and slower economic growth in 2023. It followed a rebound in 2021, strong but below GDP growth, and the sharp drop in 2020 linked to COVID. As you can see on the figure below, the decoupling of primary consumption and GDP is accelerating. The reduction in primary energy intensity is 3 times higher since 2022 than over 2010-2019. If we look at final energy consumption, we see that it remained almost stable over 2010-2019. The slight increase in transport was offset by decreases in other sectors. Since 2019, final consumption declined in all sectors by 1.2% per year overall. It decreased even faster in industry and services due to the surge in energy prices, which has forced them to limit their consumption, to limit their expenditures. First estimates for 2023 suggest an overall reduction of 2% in final consumption, driven by industry and mitigated by a slight contraction in transport consumption. At country level, trends since 2010 are more contrasted than the EU average. Final consumption in dark blue remain roughly stable in 13 EU countries, including the two largest. They are circled in orange. Final consumption fell despite economic growth in 8 countries on the left of the figure, and grew less rapidly than GDP in the remaining 6 countries on the right of the figure. As a result, final energy intensity in light blue declined in all EU member states. Now, if we compare trends for total energy supply in orange and final energy consumption in blue, we observe that they are quite different. At EU level, in red on the figure, and in most member states, total supply decreased faster than final consumption and often much faster. There has been a decrease in total supply despite an increase in final consumption in 5 countries, the ones circled in blue, and there has been a lower increase in total supply than in final consumption in the 3 remaining countries, circled in green. These divergent trends can be explained thanks to a decomposition analysis. Between 2010 and 2022, total energy supplies decreased 7 times more than final consumption, by 170 megato compared to 24 megato. half of this difference is explained by changes in the power sector. A higher share of renewables and lower shares of nuclear and thermal reduce total supply by 65 megatonnes. And the improved efficiency of thermal generation, thanks to a shift from coal to gas and more efficient plants, contributed to a reduction of 19 megatonnes. If we have a look at energy-related CO2 emissions, we observe a decoupling between them, in gray, and total energy supply, in orange, since 2010. In 2023, CO2 emissions were 27% lower than in 2010. 60% of this reduction is due to the decrease in energy supply, and 40% to decarbonization, meaning a decrease in the average emission factor. A detailed analysis by country will be available in the presentation you can download after the webinar, but for now, let's move on to the analysis of energy efficiency trend with Bruno.
Good afternoon, everybody. So we'll shift to energy efficiency. And in Odyssey, we have several hundred of indicators of specific consumption that are measured in physical units at a detailed level, so as to measure as accurately as possible energy efficiency. For transport, we'll use liter per 100 kilometer or TUE per passenger kilometer for cars and so on. For household, we'll have indicators in TUE per square meter, for heating, kilowatt hour per appliance. What I want to say is that we have many indicators, all of them in different units. Each time we take in the best unit and the best indicator to measure energy efficiency. From the trend we can have on the different indicators, we try to aggregate them to be able to measure energy efficiency at the level of sector. For that, we have developed an energy efficiency index that we call ODEX, that we have presented already several times, but just I summarize what it is. The ODEX for each sector is calculated, first of all, by expressing each trend in specific consumption by end use or subsector as an index of variation, so that take into account the fact we don't have the same unit for all the indicators. And then we calculate the weighted average index by weighting each of the index of variation by the share of each end use or subsector in this sector's consumption. As a result, we calculate an ODEX based on 30 end use, subsector, or transport modes. And even in some case, we go into more detail, like for car, taking into account new car, existing cars, same for dwellings and so on. But I don't want to go into more details. So now let's look at the trend in this energy efficiency index. On the graph, you have the index for the different sectors in different colors, starting 100 in 2000. So if we have 70, like for household in 2022, it means energy efficiency has improved by 30%. Having in mind that very often energy efficiency progress is measured in percentage per year, we express this index in that way. And on average, since 2000, we can say that energy efficiency has improved by 1.1% per year in the EU. And this improvement, this is something that is new compared to the previous webinar we did on the same topic. These improvements have accelerated since 2019, especially in the two recent years, 2021, 2022. This is new because we observed before there was a slow progression between 2014 and 2019. So this is the good news. Energy efficiency improvement are accelerating again. On the overall period, the larger improvement were observed for household, 1.7% per year, followed by industry, and transport and service are lagging behind with improvements that are a bit disappointing, slightly above 0.5% per year. The recent intensification in energy efficiency progress may be partly linked to the high energy prices and to response of consumers, sometimes through investment. So this can correspond to a durable change, sometimes to behavioral change. For a lot of our indicators, we try to take into account these behaviors and to remove it, but sometimes it is not easy because of the lack of information. This efficiency trend resulted in energy savings. So we can calculate what it means in terms of savings. For all the final consumers, in 2020, we can say that 240 million ton oil equivalent have been saved at the EU level, which represent 27% of the final consumption. This means that without this saving, the final consumption would have been 27% higher than what is shown in the statistics. Together, industry and household accounted for over 3/4 of these savings, while representing 53% of the final consumption. This means that transport and services are underrepresented compared to their share in the final consumption, especially transport. Now, if we look at the trend in the energy saving, next slide, please, over the year, what is striking is the acceleration we can see since 2020-22, or 2020-22, especially after the slowdown we observed between 2015 and 2019. Until 2014, we had a stable yearly addition of saving estimated at around 10 million ton oil equivalent per year, which was reduced significantly between over 2015-2019 to around 6 MTOE per year. And now, in the two last years, we had quite a significant increase in the overall savings. Since 2020, so in the period with a very high level of energy saving, industry household accounted for most of these savings, about 3/4, of which 1/3 just for household. And this is about the same distribution over the period 2015-2019, when there were limited savings. Then, if we take into account these savings, which are shown by the dark green on top of this graph, and if we take into account the saving at the level of the power sector, due to the change in the power mix, the fact is what was explained by Estelle before, we replace inefficient thermal power generation by renewable, which are assumed to have 100% efficiency. We have again saving at the level of the power sector, which is shown in light green on top of the graph. So this graph shows what would have been the primary consumption in the EU if we had not registered savings. Total energy saving contributed to almost 400 million ton oil equivalent in 2022. This is the sum of the two green area, from which 60% correspond to the final user. This is what I showed before, and 40% from the power sector, and which is particularly increasing in recent years. This means that energy saving now represent almost the first fuel, slightly behind oil. But if we had started the graph in 1990, energy efficiency would be by far the first fuel, which is the what is looked after at the EU level by the European Commission to recognize energy efficiency as a first fuel. Now let's go further in the understanding of the change in the final energy consumption, which has decreased over the period 2010-2020, as it is shown here. And this is a result of different factors. First, you have what we call the activity effect, which corresponds to growth in the industrial production, in the activity of the service sector. demographic growth, increase in traffic in the transport sector, increase in the number of equipment in the household sector, and this contributed to increase the final consumption by 101 million ton equivalent. And this activity effect can be broken down by a sector, about 1/3 in industry, slightly more than 1/3 in industry, 1/3 from household, of which half from demography and half from higher comfort, meaning more appliance, maybe a larger dwelling and so on. Energy savings, which represent 127 million ton oil equivalent, more than offset this activity effect and reduce consumption by 127 million ton oil equivalent, of which 40% is coming from household, 1/3 from industry, 20% for transport, and around 10% in services. All these are rounded numbers just to give some order of magnitude. What is interesting is that the climate effect, which is the third larger effect, contributed to reduce consumption by a further 44 million ton oil equivalent. So it is almost the equivalent of 1/3 of this energy saving. Why this climatic effect? It just comes from the fact that as we compare 2020 with 2010, the climate in 2020 was much warmer than in 2020, especially in winter, which explains this decrease in consumption. Then we can have a look at what happened in the most recent year for which we have all the detailed data, 2022. In 2022, the consumption decreased by 36 million tons of oil equivalent. The activity effect would have increased the consumption by 26 million ton oil effect, but we have different factors that have offset this increase. We have energy saving, 28 million ton oil equivalent. We have climate effect again, because 2022 was warmer than 2021. And also structural effects, meaning in industry, there was a higher production by less energy-intensive industry, which represents 70% of the structural effect. The other 30% correspond to model split in transport towards less energy-intensive modes, which is something interesting and new. Well, if I conclude this section on energy consumption and energy efficiency, since 2020, we have observed a succession of unusual years, making it difficult to outline trends for the future. There has been the collapse of demand in 2020, then a very strong rebound in 2021 that was quite exceptional, and then a very significant decrease in consumption since 2022 and in 2023 due to the high price and supply constraints. What is sure is that there will be an increasing decoupling between final and primary consumption due to the growing share of wind and solar, as no losses are accounted for the generation of renewables in the primary consumption. What we can say also is that energy efficiency improvement of final consumers has accelerated since 2019 after a slow progress, and this is partly due to higher energy price, and some of it may be partially reversible. We'll see in 2024 and later on if prices are going to normal level, if there is reverse or not. The progression of energy efficiency has been by far the strongest for household, mainly because it has been linked to multiple regulation and incentive at EU and national level. Then, to go back to one question that was raised in this webinar, and that will be continued by my colleague Wolfgang, is are we on track with the target? In the Energy Efficiency Directive, EED, at the EU level, there is one article called Article 4 that provides targets of absolute level of the consumption in 2030 for primary and final consumption. This is shown by the circle in 2030. This is the level where we we are supposed to go to meet the target. As I explained, the integration of renewable in the power mix is reducing rapidly the primary consumption, and we think that it will continue by 2030. So it seems that the target for the primary consumption should be reached. For the final consumption, it will depend on many factors, as you have seen before. One of them is the rate of the economic activity. Another is the impact of the energy efficiency policies, especially in the future. This is the topic of the last part of the presentation, and also consumer behavior, whether some of the change in behaviors will be kept or not. So now I leave the floor to Wolfgang.
Yes, hello together. I will keep my video switched off because I'm not totally sure about the stability of my connection, so we'll switch my video off. In this third part, I would like to point to the role of energy efficiency policies in the picture which Bruno has shown, and just to recall the slide which Bruno has shown a few slides previously. You see here the yearly savings which are derived in different periods from 2000 to 2007. From 8 to 14, and some slowdown from 15 to 19. So we move here in the range of 10 million tons of oil equivalent per year. In the later period, a bit down to 6, and then this somewhat higher savings from 2020 onward here. And the question is, what was the role of policies in here? And this I would like to try to elaborate a bit more in the following minutes. Next slide, please, Estelle. Here to the right-hand side, you see different approaches to study the impact of energy efficiency policies. Especially for the left-hand part, the left two columns, we made use of the MUIR database, which is an energy efficiency policy database already mentioned here at the beginning and part of the Odyssey MUIR project. The column which is totally to your left in the right graph with the policy impacts is derived for the period of 2010 to 2020, so the past decade, and I made use for this of another tool which I presented earlier in this webinar series, that is the energy efficiency scoreboard. And on average, the policy impact that was derived for that period was somewhat above 4.3, around 4.3 million tons of oil equivalent on an annual basis. And if you compare this value with the savings which are derived from the top-down approach, which is the indicator approach, which is in a way kind of for this decade a mixture between the second and the third column in the left graph, you can calculate that roughly spoken the effects of the policies compared to the top-down savings was roughly about a 50% contribution to the reduction in energy demand. Bruno, he mentioned a number of other factors which are active. There are autonomous changes going on. There are also, especially in some years like the Ukraine war, behavioral changes and so on. So other factors next to policies have an impact, but nevertheless, from this analysis, it can be shown that half of the savings can be related to policies in that period of time. The second column in the right graph takes a look to the future, and is the analysis has been taken with an analysis tool which we are presently developing in the Odyssey MUIR project. We call it a policy assessment tool. which provides information about the impacts of policies extracted from the MUIR database, which is strongly also influenced by the reporting of the member states in the so-called national energy and climate plans. And one can see from this analysis that what is at present in the MUIR database and also in these, at least the draft NECPs, ends up with a similar value of around 4.1 million tons of oil equivalent annual savings due to the policies which member states have been announcing. And that is in a way a little bit deceiving, because there is not an acceleration visible on this. You also see in the left two columns some sectoral split with the sectors which were most prominent here, like the households, especially in the past decade, but also in some projected period. Apparently transport also could make a large, more prominent contribution, and we saw that this sector is really in a need for this. These around 4 million tons of oil equivalent annual policy savings are also confirmed by the third column. This is derived from an analysis of the European Commission from the assessment draft of the national energy and climate plans towards the end of last year. The figure derived from here is around 4.9 million tons of oil equivalent per year, observed in what is promised in the draft NECPs. And close by, in months of June, a number of member states will submit their final NECP for this period, and some member states maybe a little bit later than the end of June. But this will be an occasion also to verify whether this value of 4.9% or 4 to 5%, sorry, 4 to 5 million tons of oil equivalent per year is also observed in the NECPs which are forthcoming, the final NECPs. Compared to the target, there was no sectoral breakdown here for this third column, and the same naturally also for the next one. The next column, the fourth one, in the right graph, shows what is necessary to achieve the European energy efficiency target of 11.7% compared to a baseline, the PRIME's 2020 baseline. And from there one can see that the double of the left of the third figure, or of the first and second, sorry, of the third column or of the first and second column, needs to be achieved in order to really come to the 2030 objective, as we have set it presently with the recast of the Energy Efficiency Directive. For 2021, there is also an overview from the so-called Article 7 measure the database, now Article 8. This tends to indicate that in this period of time there have been more savings achieved, which would confirm or be compatible with what Bruno has shown on the left-hand side in the top-down indicators, which shows an enhancement of the savings in the period of 2020 to 2022, which partly is due to behavioral changes, certainly in 2022. But according to this first look to these Article 7 impacts, it could be, at least for this period of time, also be linked to policy measures. But the comparison with the longer term views, at least from the draft NECPs, still does not translate into a picture which makes being confident that this is going to translate over the next seven years. Next slide, please. This summarizes the contribution of energy efficiency policies. First, you saw for the period for the past decade, 2010 to 2020, energy efficiency policies have contributed roughly 50% of the observed top-down savings, and as said, the remainder is linked to autonomous savings, to previous policies, but also to changing behavior in 2022 and so on, which raises the question of permanence of such savings and so on. This was an analysis derived from the Odyssey Muir EECP energy efficiency scoreboard. The second conclusion is that the analysis carried out on the Muir database with this newly developed policy assessment tool shows also saving of a similar amount, around 4.10 million tons of oil equivalent per year to the end of this decade, and this is in a very similar manner mirrored in the figure which the European Commission came up with the analysis of the draft NECPs to be further investigated, to be confirmed, or to be enhanced perhaps by the forthcoming NECPs. And finally, the analysis of the Commission on the Article 7, Article 8 contributions indicates a substantial increase in that period of time that would be in line with the observed top-down savings in that period, but still, as said, in comparison with the NECPs, to be further confirmed. Estelle, we have still one slide here, or I'm not totally sure. No, it's the final one here.